Okay, so we're here at discussing what kind of number pi is. 3.1459.
159.
I only write the 0.14 because what's the idea here, right? Yeah, it goes on forever in decimal form. And what exactly is going on? What is special about pi? So it goes on forever, yeah. So it is what's called non-terminating. It does not terminate. And what also, which makes it even more interesting, because for example, what makes pi different than a number, say like 1/3? I think it's important that we review this. So like 1/3, what's 1/3 in decimal format? 0.3 repeating, correct. What makes pi more unique than 1/3?
Because it's not the same number over and over. It's a series of different numbers.
Ah, correct. It is not repeating. So what makes pi interesting, and this is a mind-blowing concept, I think, to most people, including myself, is that pi, when written in decimal form, it is non-terminating and non-repeating. So there's no pattern to it, forever and ever and ever. And you can even go online and you can find a website that is pi to 1,000,000 digits, and that still is not the value of pi. There's no pattern to it. That itself could be discussed on its own. But pi is still what kind of number? Is it a variable or is it a constant? It is a constant, yes. It's the same number. It does not vary. It is a constant. We just use the Greek symbol to represent it. So again, 0 divided by, now pi plus 1 would simply be another constant, right? The constant plus a constant is just another constant, so this would still be 0. Okay. So do we agree that division is the inverse of multiplication? Okay, so could you argue for someone to understand this simple expression, say 0/3, you could say, well, ask yourself, what times 3 would give me 0? Right, is that a way to understand it? Probably, right? Same thing here, what times, the whole value here, pi plus 1, would give me 0? 0, okay. So, let's make sure we understand. What is this, 0 divided by 0? In fact, let's before we get to there, let's do something else besides 0 on top. Let's do this. I apologize. Let's do 3 divided by 0. So maybe, so I hear it could be 0, it could be 3. Any other thoughts? Don't be afraid to, if you think you might be wrong, just what are your thoughts? This is because we're here to learn. So 3 divided by 0. That was not necessary. So 3 divided by 0, 0, 3. So let's go back by the rules of, okay, we kind of agree along the lines that division is the inverse of multiplication. So 0 times 0 is 0. 3 times 0 is 0. Okay. So here's the thing you need to know, that you definitely need to know. And you guys are now in Algebra 2, so you need to definitely know and understand that division by 0 is undefined. It has no definition and it has no value. And of course, undefined is not the same thing as 0, because we clearly learned from the video, the number file video, that 0 is a defined value. And it is even. Okay? So 3 divided by 0 is undefined. So what about 0 divided by 0? I want to hear your thoughts on this. So you think 0. So 0 times 0 is any number. Okay, so I hear 0, any number. Or do you think it's undefined? 1 alone, okay? 1. Okay, so it's up here 0, any number 1, and undefined. We actually say that it is undefined. So do know this, that 0 divided by 0 is undefined. It was probably easier to express it this way than to say any number, because you can say, well, why isn't that any number? I mean, any number times 0 is 0, right? And I've thought that myself, but we just say that division by 0 is undefined. So that's something important to remember. Let's go on to the next slide. So some stuff that we should know. Okay, so what is 0 to the 5th power?
0.
1.
0 to the 5th power is 0. Okay. What is 0 to the 1st power? 0. And what is 0 to the 0 power? Undefined 1.
I know
0.
Yeah.
It is 1. Something important to know here. Basic things that just seem to go out the window and you don't see them very often, but we should definitely know these things here. This is what's interesting about 0 as a base raised to some exponent. 0 pretty much raised to any exponent, any real exponent, we'll say that to be safe, is 0, except for when you raise it to 0. When you raise it to 0, we just say that is 1. And I'm sure there is some very complex proof that we're not going to go into, but just do know that 0 to the 0 power is 1. Okay, so what else do we need to cover for involving 0? Well, did you guys ever learn factorial? Does that sound familiar at all? Yes? I did not have to do that. Do that and just go over to the next slide. So, what is 4 factorial? Raise your hand if you've never studied factorial. Okay, raise your hand if you have covered the exclamation point. Okay, interesting. Okay, so now we're going to learn this real quick. So 4 factorial, what this essentially is equal to, and this will be covered later on in the course because this is going to be dealing with basic combination and permutation, and we'll get into that. That's basic statistics, which I believe this course probably will touch on because your EOC, we're still not 100% sure what's going to be on it. So we made that basic statistics. So 4 times 3 times 2 times 1, you could argue that this is equivalent to 4 factorial, which would be what? Anyone? Mental math skills. Good for the brain. 24, good. Okay, so 3 factorial would be 6. Would be 6. But you could think of it. No, I won't say that yet. I want to see where to go with this. Let's go. All right. So now, what about 1 factorial?
0.
It is 1. It is 1. And what about 0 factorial? 0 factorial is actually 1. So it's some unique properties. Since we're on this topic today, we're going to discuss these unique properties. So here's a way to think of, okay, why is it 1? Okay, so for a simple explanation, you can think of it like this. 3 factorial could be thought of as 4 factorial divided by 4. And 1 factorial could be thought of as 2 factorial divided by 2. You imagine if you expanded 4 factorial, you would have this, which is 24, over 4, which is 6. 1 factorial, if you think of it as 2 factorial over 2 in this pattern, 2 times 1 over 2 would yield 1. And if we think of 0 factorial as 1 factorial over 1, it may make more sense, or it may come together in your mind. Okay? All right. Let's go to, now if you guys know, you guys should be familiar with, I think you should be familiar with radicals. So if I say the cube root of 8, what is the cube root of 8? This 2. Okay. What about the, say, the square root of 8? You guys ever done it before? Simplifying radicals?
Yeah,
Comes from 1 maybe?
yes, it's
So there's a really easy way to do these, and I hope that you guys were taught this way, but if you weren't, let's go over it now. So to simplify any radical of any whole root, let's say any whole root greater than 0, we do what's called prime factorization. Sound familiar? The reason it's called prime factorization is because you are breaking it down to its prime components. The smallest prime number that is a factor of 8 is and 2 times and we keep going down. They're the same question. The smallest prime number that goes into 4 as a factor of 4 is 2, and 2 times 2 is 4. So any whole number 2 or greater can be broken down into its prime components. So 2 times 2 times 2 is 8, which we kind of already knew that because of what we demonstrated here. But no matter what the root is, as long as it is whole number greater than 0, we can do this. We can say, okay, now if it's a 2, it's the square root of 8. I didn't have to write the 2, right? I didn't have to write the 2. It's understood to be the square root of 8. What's nice about this is then what you can do, and I'll do yellow, we can say, okay, I'm going to take out pairs, and whatever is left over, that'll be what's left underneath the radical. So this would be, if I take, because the square root of 4 is 2, right? That's why I'm able to take this out, so to speak. So I'd have a 2, because it's a pair of 2s, because it's a 2 is the index, right? And what's left over is this 2. So it would be 2 square root of 2. And this is the most perfect way to write this number here. There is no better way, because this, like pi, is irrational in the sense that if I wrote this in decimal form, it would go on forever, and there would be no pattern. So we'll leave off with that, and I'll see you guys tomorrow.